Hi, first I'm going to introduce how to run the code. So here we can simply come to the terminal and use Python program.py, which is the entrance of our code. And then we can see the size of, we can pick the size of the ball, for example 2, and then we pick 5 plies, and then we can see this ball drawn here. And then we go to say, I want to draw this line. So first will be the vertical index, and the second will be the horizontal index. So 0, 1, and then we can quickly see this is what I drawn, and this is AI returned. So we'll, and then it will keep going and so on after the game finish. And then I'm going to introduce how each file presents. So the program is the entrance of our whole game, and there is a board class and presenting the game board. And there's also node class presenting each node like for our game. And here's the algorithm we are using for Minimax. So for the game board here, we make the board follows the design pattern of singleton, thus we can have only one instance and make sure we are always drawing on the same board. And then we have 3 matrices for the UI board. The board matrix is to store the value in the board. The edge line matrix is to store the horizontal line, and the V-line matrix is to store the vertical lines. And then we have the AI score, human score here, because we like to have them based on the board. And here we have all possible moves, so we can find out all the possible moves for the next step. And we have how to get a score. So we assume when user can close a box with a line, he earns the score of that box. And we also consider connected boxes and make sure they are not drawing outside the board. And we have the function to convert this line into our backend 3 matrices. We have the draw line function, and also this is the draw board function that is only for the UI board based on our 3 backend matrices. And then we talk about how the Minimax works. So AI move is the entrance of the Minimax. So when the user draw a line, we pass how the user draw here. And then we're going to turn to the Minimax with this information. After Minimax return the results, we're going to have the best evaluation. So with this best evaluation, we'll get the best node. So we can draw this best node at here, like UI draw finally, and then with the score. So for the Minimax function, we have 3 main parts here. The first main part is going to have the stop condition with the leaf node here. So we use the heuristic evaluation function here. And then we have max player and the mini player. For the max player, he wants to pick the maximum from the options that his opponents will pick. And for the mini player, he wants to pick the minimum from the option that his opponents will pick. And we also have the alpha beta. So the alpha beta is setting from the node. So each node will have its own alpha beta. And then the alpha is initial to the minus infinity. And the beta is to the largest number. And then come back here, we have the condition how to prune the children. So for that, for max, we prune it based on the here. the beta, if less than alpha, then we say it's going to prune. So this is because for max player, if beta less equal alpha, it means it already have a beta node. It's same to the mini player as well. So if beta less than alpha, it also means the mini has a better option already. That's it. Thank you.